the next area that we want to talk about are called firefighting and emergency egress, as well as what we call hazardous waste operations. In plain words, all of this is tied to the fact that we've either got an emergency going on or a potential emergency that can take place inside of a facility, and what should our actions be. To understand the whole process, we need to understand this thing that's called a fire triangle. A fire triangle consists of three elements. You've got to have an oxygen source, you've got to have a fuel, and both of those commodities have to be of an equal proportion that once exposed to an ignition source that they will burst into flame. Once again, this is referred to as upper explosive limits and lower explosive limits on the MSDS sheet. The next thing we need to talk about then, I guess, are the 5 different classes of fire extinguishers that are out there. There are 3 that are most common to all of us, and we've all heard about A, B's, and C's, so we'll begin there. The Class A fire extinguisher is distinguished by the fact that it's got a green triangle with a black letter A in it. A little cartoon label depicts a trash can that's on fire, as well as sticks or logs that are on fire. Commonly, we refer to these things as ordinary combustibles. Examples of these would be paper, wood, most rubber products, plastic, or textile products. As you can see, they call these ordinary combustibles. Based on our definition earlier, we know that a combustible is a material that has to be heated above 200 degrees before it gives off a vapor that's ignitable. So we start to see how our MSDS sheets and this firefighting stuff kind of tie back together with each other. I always tend to think of these Class A's I call combustible solids. And the reason that I use the word solids is because when we look at the Class B's, we start talking about flammable liquids. And if I can distinguish between solids, Class A, and liquids, Class B, it helps me keep them separated when I go to grab fire extinguishers. The most common agent that's used to fight a Class A fire is an ordinary water-based fire extinguisher. It's referred to as a clean fire extinguisher because once the water is dispersed, it leaves no residue, does not contain an irritant, and therefore once the fire is put out, it's very easy to go in and do a cleanup. Class B fires, on the other hand, are symbolized by the red square with the letter B, and the label itself contains a fixture that us guys in the military are very familiar with called a jerry can, which contained our fuels, gasoline or diesel, oils, 30 weight, 10 weight, FRH fluids, solvents that were used in the field to clean our weapon systems. So we understand flammable liquids. So then what are flammable gases? Some of the flammable gases that come to bear here are things like butane and propane that can be used in handheld torches or different lighting mechanisms that will burn readily. Any of these are referred to as Class B fire agents. Example, and the best agent that's used primarily used in Class B fire extinguishers is carbon dioxide, CO2 fire extinguishers. CO2 fire extinguisher, just like the Class A fire extinguisher, also is a clean fire extinguisher because once the CO2 gas is released, it extinguishes the fire but leaves no residue. So once again, Class B CO2 is a preferred. All too often, though, we've gotten kind of past all that where we want one fire extinguisher that covers a wide variety of different fire conditions. Sometimes this is referred to as a dry chemical fire extinguisher, an ABC fire extinguisher, meaning in the fact that with this agent that's inside of here, I can fight Class A, Class B, and Class C type fires and not have to worry about it. One extinguisher does all. The thing that we need to understand about ABC or dry chemical fire extinguishers is that they are what we call dirty fire extinguishers. By that I mean when they're deployed, the chemical that's in is a very highly corrosive commodity and it's a strong irritant, which means you better pay attention to which way the wind's blowing because once you deploy that chemical, if it blows back on you, it's going to cause extreme irritation to your skin or your respiratory tract if you're breathing it. So we start to understand the limitations of the Class B chemical fire extinguisher. One of the most effective Class B fire extinguishers that I've seen in my lifetime is what they call Purple K. Purple K is used around a lot of your airfields, around a lot of different petroleum storage facilities. because it is so effective at interrupting the chemical chain reaction in a fire and putting it out immediately. But just like the other dry chemicals, it's also a very caustic solution. It causes severe corrosion and will require that system or component or that engine to be torn down and rebuilt as part of the process to avoid it becoming ruined. The most common application of Purple K most recently I saw was at one of the NASCAR races where a guy put a car into the wall, took out the fuel cell, the car burst into fire. When the rescue fire team arrived on scene, they deployed a fire extinguisher, and the purple cloud came up, identifying it very distinctly as being a Purple K dry chemical fire extinguisher. Class C fires. Class C fires are identified by a blue circle with the letter C in it. And if you look at the label, it kind of shows an electrical plug. And the way I challenge people here is, can you put out a fire, an electrical fire, with a fire extinguisher? And right away, a lot of people will buy into it and they'll say yes, but in reality, the answer is no. You cannot put out an electrical fire with a fire extinguisher. The only way to stop an electrical fire is to de-energize the electrical circuit. Once we de-energize the electrical circuit, now it changes from a Class C fire to a Class A fire, because most of those components are going to have plastic casings or something along those lines. So then we treat it as if it was a Class A fire. So people say, well then, why do they say electrical hazards in Class C fire extinguishers? And the answer is that's a label that the NFPA put on there to warn the user of that fire extinguisher that should he accidentally come in contact with that fire agent coming out of that fire extinguisher, and should it come in contact with an electrical source, that it will not conduct electricity back, causing him to be shocked or electrocuted. That's one of the misnomers of a Class C fire extinguisher. The next area we want to enter into are Class D fire extinguishers. Class D fire extinguishers are used for combustible metals. I tell people it's very easy to identify Class D because of the old Texaco star. Got the letter D in it, yellow star. How do metals catch fire? That's simple. They have to be heated. Once they heat and go from a solid to a liquid, in their liquid form, now they're giving off vapors that is highly flammable. Examples of these combustible metals are very easy to identify in the fact that products like magnesium and any of the aluminum products that we find on board automobiles, intake manifolds, rims on the cars, front and aft casings on alternators, emission control pumps, all those contain aluminum parts. Anytime you've got aluminum, you're going to find a degree of magnesium to give it lightness and to give it additional strength. Magnesium, or these types of elements, when they're involved in a fire, they don't pose the problem until they get heated to the point where they go from solid to liquid. So once again, if you're involved in a wreck in a car, turn off that ignition switch, and hopefully if the gas ignites down on the intake manifold or down onto the exhaust manifolds, you're able to treat it as a Class B fire and control it, and not allow that incipient temperature to reach the point where it melts the aluminum and exposes magnesium at that point in time to auto-ignite. A lot of times on the news at night, you'll see cars that are out on the interstate that the fire departments have simply stood back and watched burn. It'll be the rims that are burning. It'll be the engine compartments that are burning. Why? Because these aluminum products have gone out of the incipient stage into molten metals and spontaneously ignited. Class D fire extinguishers contain a powder system. They are low-pressure powder systems, which means that the powder that's in there comes out at a very low pressure, and it basically builds a mound over this object that's on fire. This can be very tricky out on the interstate if winds are blowing, because you can't ever get it built up to the point where it can overcome or cover with all degree of certainty that thing that's on fire. And once again, if air gets back to it or the powder gets blown away, it'll reignite. But the way that it functions is the powder covers it, allows the metal itself then to start the cooling process. Hopefully it goes from liquid back to solid, no longer transmitting vapors. The last class of fire extinguisher we want to talk about is one that's been on the street for about 3 years. These are called Class K fire extinguishing systems. They normally find these systems in what we call commercial kitchens, where they got the deep fryers and the nice little grills that they cook our foods on. In these commercial kitchens, what they do is they install these banks in the wall. And when they install the banks in the wall, they've got what they call halon gas in them. Once the fire extinguisher system is activated, the halon gas comes out, laying down over the top of the grill and the fryer, extinguishing the flame, creating an oxygen-deficient environment. Microseconds behind the initial deployment of the halon comes a foaming-type commodity behind it, which then lays in on the top of grease in the fryer and across the top of the grill, putting a layer of foam between the air on top and the commodity that's underneath that's been heated to a vapor-giving intensity. By doing that, what it does is it cuts it off and it keeps it from being able to reignite. Then once again, just like we do with metal fires, we have to remove the source, the electrical feed or the gas feed that's feeding the fryer, and that keeps us from being able to reignite the fire. So now that we've talked about the different classes of fire extinguisher, how do I deploy a fire extinguisher? The best way to do that is try to remember a pro word like PASS. PASS is an acronym that stands for pull, aim, squeeze, and sweep, and we're going to talk about those individually. But before we do that, let's look at the statement that's on the screen. Keep your back to an unobstructed exit. What we're saying here is that as you go to try to deploy a fire extinguisher or to egress out of a building using a fire extinguisher to help you get out, you never want to turn your back on something that's burning. If you put the fire out, you continue to face it and back out the doorway. That way, if it reignites or if you have a flashover, you're facing it. You're not getting burnt from the backside. Additionally, it talks about stand back at least 6 to 8 feet from the fire and then. This is a true statement if what you're using is a CO2 fire extinguisher. But what you need to understand is that every fire extinguisher manufacturer and every fire extinguisher has a different safe approach distance before you deploy it. That's why you have to read the label on the fire extinguisher. Item number B or item number 2 will say, remove nozzle, begin employment at a different distance. Good examples here, as I said, carbon dioxide works well at 8 feet. Most of your halons or handheld fire extinguishers are talking 10 feet. ABCs are 10 feet. But that water-based fire extinguisher, if you look at the label on it, it will go out to as much as 20 feet as the initial starting point to engage a fire. If you do not start at those distances or you close on the fire before you start, you're putting yourself in an unnecessary risk. Once you've attained the proper standoff distance, like it says, pull the pin. Pulling the pin sounds simple, but if you haven't got a good positive mental control over yourself in this emergency, and you grab the handle and try to pull the pin while you're holding on to it, it'll bind down on the pin and will not allow you to pull that pin out. So what I try to tell people is, once you set the fire extinguisher down, hold it by the collar, then take the pin and give it a quarter twist, which will break the seal that's on there. Once you give it the quarter of a twist, anybody can pull it with their little finger. Second part of that, the A stands for aim. I say aim at base of visible fire. Aim as low as possible at the base of visible fire. If it's a trash can and you aim at the bottom of the trash can, that's not going to work. But if you aim at the base of visible fire, which would be the lip of that trash can, and get the agent over the top of that lip, now you can control that fire. The third letter, S, stands for squeeze the lever. This is one of those things that if you get them out of sequence, like squeezing that lever and then try to pull the pin, it will not work. So as you can see, you've got to do these in proper sequence. Squeeze the lever. When we squeeze the lever, it releases the propellant and the agent out through the nozzle in the direction of the fire. The fourth letter, the second S, stands for sweep. And when they're talking about sweeping, we're not talking about vigorous back and forth movements in rapid succession. What we're talking about is with your thumb at the 12 o'clock position on that horn, you should not have to move your thumb more than the width of your nail, left or right, to get 6-foot overrun on each side. Anything more than that will allow air to come in around on the side, allowing that fire to reignite. And now you're back where you're starting. Here at the Fire College in Ocala, when I was going through the fire trainer school up there, I literally watched some of my fellow students chase a fire around a 20-gallon pan because they never controlled that leading edge, and all they did was change it, allowing air to get around it. So that's something to remember. We've talked about fire extinguishers. We've talked about the capabilities. We've talked about how to use them. The other things that we deal with out there in the real world are, what do we do if we have a spill? What actions do we take to protect ourselves, to protect our fellow coworkers in an emergency situation? Most of this is found up under the OSHA HAZWOPER standard, or Hazardous Waste Operations, another acronym. To understand this, we need to understand that, first of all, in these roles, there's training that's required. Emergency response classes can vary from as much as 1 hour for the awareness training that a first responder gets to upwards of 40 hours plus for an incident commander. So depending upon that degree of responsibility, it's going to dictate how much training is required. By the same token, certain classifications under the HAZWOPER Act are going to require mandatory 8-hour refresher classes or mandatory 24-hour refresher classes within that standard. So let's take a look at this slide. The slide's broken into two basic teams, is what I like to call them. We call them offensive teams and defensive teams. And the reason that is done is because there are different actions. When we think of a team in a sport as being on the defense, their job is to basically prevent the other team from scoring or prevent the other team from expanding their control over that field. Same thing's true in the HAZWOPER world. As a first responder awareness trainee individual, which everyone who works in a facility is, our primary role there is that of get up and get out. We've already talked about that. And that is our only role, the defense of ourselves and getting out of the facility. Where this changes is when an employer has certain people that have to remain behind to turn off switches or turn off a valve in order to better protect the facility in case there's a massive leak. But they also are called first responders, but this is where it changes from an awareness level training to what we call an operations level training. A first responder operations employee is given 8 hours of training and taught how to deploy defensive strategies to safeguard a facility or a building and set it up in such a way as that no other employees would then enter into that area where the leak occurred by accident. And as I said, this is where it changes from defense. The next level that we talk about is where we go and we start applying offensive strategies. So now we're going to take the battle to this release that's taken place. The two primary people that are out there on that front line are what we call the Hazardous Waste Operations Technician, or HAZWOPER Tech. The HAZWOPER Tech is given a minimum of 24 hours of training, and it's his responsibility to go in and close the valves, turn off, secure the drum that's leaking, put the plugs and patches on. He takes the fight or the battle to the battlefield. The other side of that are these individuals we call HAZWOPER specialists. By virtue of the vocabulary specialist, we're saying that he has special knowledge or special skills that are going to be required of maybe by that incident commander to help him take control of this situation. A good example of a specialist might be an electrical engineer that understands how all the valves are wired together, and he can look at the schematic and say, look, if you're going to shut that valve off, you've got to turn circuit breaker number 13 and panel number 1504. Now he's brought to this battlefield specialized knowledge of the systems that are causing the problem. The final level is the incident commander. The incident commander is the individual who has the overall responsibility to make sure that this response is conducted in a safe fashion. In most cases, the incident commander, after 9/11, has been designated as the senior fire representative on site. And then, by the way, I might add that he has the ability to make the decisions to tell the police what to secure and not secure. And in this scenario, as the firefighters on scene, as the incident responders, these individuals have overall authority, blanket authority, over making decisions. Interfering with them with the response of their duties or the execution of their duties is a felony offense after 9/11. So Homeland Security has taken a significant change of approach towards this whole HAZWOPER issue after the hazards had developed there.